Assalamualaikum warahmatullahi wabarakatuh. My name is ADNAN bin Abu Bakar. My matrix number is DE210067. And today I'm going to present to you about our group project assignment for mechanical science, which is to design a fluid delivery system for POME. So first and foremost, this is our team member. The first one is Muhammad AIMAN bin Muhammad FAUZI. The second one is Cikgu Muhammad IMRAN bin Cikgu MAWARDI. The third one is myself, Ahmad ADNAN bin Abu Bakar. And the fourth one is Muhammad LUQMAN bin Muhammad SAFU'AN. So for introduction, POME is a complicated mixture that consists of water, oil and suspended solids. It presents a huge environmental concern due to the high organic content. It contains as well as the possibility that it will release pollutant if it is not controlled in the appropriate manner. Transporting this byproduct from the processing facility to the designated POME pond in a manner that is both safe and effective is an essential component of POME management. So as a group that has been entrusted with building a fluid delivery system for POME, it is vital to have an in-depth understanding of the needs of the transportation system, as well as the characteristics of the waste stream that is being transported. So after this brief introduction, we will look closely at the different parts of the system, like the type of pump and motor, the materials and specifications of the tubes or hoses, and whether or not they follow the rules. So next is a problem statement. So as a worker at a palm oil processing factory, our group is tasked to design a fluid delivery system for palm oil mill effluent POME. This system shall be able to move 300 liters of POME in a minute out of the processing factory and discharge it at the designated POME pond. Design the fluid transportation system using industrial tubes or hoses and provide specifications for the motor or pump selected. Next is problem background. So this study demonstrates how fluid dynamic theory can be applied to design fluid delivery system for POME. We supported it with the design in our project, and we will infer our solutions using the chosen material and specification. On top of that, we are aware of how to implement it and a fundamental of fluids dynamics in our project.
So, for objective of the project, number one is to inculcate the importance of fluid flow measurement and its application in industry. Number two is to introduce and explain fundamentals of fluid mechanics. And number three is to imbibe basic law and equation used for analysis of static and dynamic fluids. For number four, to develop understanding about hydrostatic law, principle of buoyancy and stability of floating body and application of mass, momentum and energy equation in fluid flow. And number five is to give fundamental knowledge of fluids, its properties and behaviors under various conditions of internal and external flow.
The next part is filler table. So for facts part, it is stated at the problem statement before. And for ideas, the first one is to increase the fluid pressure so oil flow can transfer at high speed in 1 minute. The second one is use tubes or hoses that can be withstand the high pressure when oil being flow at high speed. And the third one is to use high horsepower motor, and the last one is for motor that has high reliability and long lasting. So for learning issue, we learn how to design a POME fluid delivery system. The second one is we learn the properties of tubes or hoses that been used in the system. And the third one is we select the ideal type of pump that can transfer fluid at high flow rate. And the actions that need to be done and need to know is we do research about the fluid delivery system that already exists, and we will compare to the design that we make. The second one is find out the properties of tubes that is suitable for the design. And the last one is to learn about the type of pump and the horsepower of the design.
So, for the design of POME system, the design of the fluid system for POME contains a few part of component and material used for this project, which is contains a centrifugal pump, steel pipe, and oil tank. For the pipe, we use a high pressure pipe, which is we are going to determine the material of the pipes and the diameter of the pipes. This will determine how the relationship between the diameter of the pipes and the flow rate of the oil going out to the pump.
Assalamualaikum warahmatullahi wabarakatuh. My name is Cikgu Muhammad IMRAN bin Cikgu MAWARDI, matrix number DE21006. So I will discuss about the material selection for our project system. So for the main material, we will be using the centrifugal pump, which is a mechanical device that will help to generate force that can transfer fluid from another place to one another. So this system or this centrifugal pipe can be doing transferring fluid from either long distance or short distance. It also used to boosting the fluid pressure, allowing flow it without resistance. Next, we'll be using the HDPE steel line pipe. So in this project, it will be two different diameters of pipe. First one is a small diameter for our high pressure to done the high pressure transferring, and the normal diameter for our main line. So this HDPE pipe is high density polyethylene pipe that has high durability towards the chemical reactions and high durability toward the high temperatures. It will be covered outside with the steel pipe, so combining the strength between the steel and our HDPE pipe inside, it will protect the fluids without any leakage. So next, before transferring the POME, it is important that we choose the right materials. So we have chosen the FRP tank, which is fiberglass reinforced plastic tank, to avoid any corrosion or any exposures to the UV radiation. To add on it is important to ensure that the tank can withstand the right volume or right amount of the fluids without risking any leakage to happen. So next, I will discuss about our specification. So for specifications, we're using from brand Pedrolo. It weighs about 29.2 pounds and can flow about 19,000 gallons per hour. Voltage used is 230 volt and horsepower of 3 horsepower and amperes of 14.5. The max suction it can get is about 22 feet and max PSI is 26.3. Protected by housing material of cast iron. So next, for the pipe, the diameter can be around 500 mm to 1200 mm and the length up to 1000 mm, and the material is from polyethylene, especially powder, adhesion and steel shell on the outer. So the durability is resistant to the chemical corrosion and high temperature. So the service provided for this pipe, it can flow a potable water supply, hazardous water, duct and fire protection. Okay, lastly, for the tank storage, it can hold about 5,000 liter fluid and material from fiberglass reinforced plastic and durability toward the corrosion and weather resistant. Okay, that's all from me. Thank you very much.
We'll go through about the costing. As we can see here, this project we use 3 type of component, which is the first one is centrifugal pump. We use the 3 horsepower and 230 volts centrifugal pump, and the price for this centrifugal pump is RM 3028 ringgit 50 cent. and then we go through HDPE line steel pipe. We use two type of pipe, which is the first one is 100 meter with 1200 millimeter diameter, and the second one is 100 meter long and 300 millimeter diameter. Okay, for the price for the first pipe is RM 5800, and for the second pipe is 2345. Okay, next the tank oil. We use fiberglass reinforced plastic tank, and the price for this tank is RM 5010 ringgit. Okay, next we go through the calculation for the motor. Okay, motor pump power. The motor pump power P equal to V rho G P, which is the rho is density, G is gravity, and P is pressure. And then we get the motor pump power equal to 23.360 kilowatt.
So, for our discussion, number one is, in physics and engineering, fluid dynamics is a subdiscipline of fluid mechanics that describes the flow of fluid, which is liquid and gas. It has several subdisciplines, including aerodynamics, which is the study of air and other gases in motion, and hydrodynamics, which is the study of liquids in motion. For number two, fluid dynamics has a wide range of application, including calculating force and moments on aircraft, determining the mass flow rate of petroleum through pipelines, predicting weather patterns, understanding nebulae in interstellar space, and modeling fission weapon detonations. So for number three is, fluid dynamics offer a systematic structure which underlies these practical disciplines that embraces an empirical and semi-empirical laws derived from flow measurement and used to solve practical problems.
And then we go to the consideration. It was necessary to build a system for transporting fluids using industrial tubes or hoses, and to offer specification for the chosen motor or pump. The size of the tubes or hose must also be modest, because doing otherwise will raise the pressure of the pump oil mill effluent POME flow. According to the pressure formula, P equal to F over A, which is P is the pressure, F is the force, and A equal to area. Okay, for instance, the system must be able to transport 300 liters of pump oil mill effluent in a minute based on the instruction given. To ensure that the fluid moves more quickly, we can use the laminar flow idea. If we apply the volume flow rate formula, which is volume equal to delta V over delta T, this will be doable. Determining the flow rate, which is equal to the formula difference divided by the time difference, or delta V equal to delta V over delta T. Okay, and the last one is a conclusion. In a conclusion, making a system for delivering fluids is a hard job that requires careful thought about many things. The main goal of this design is to move a certain amount of fluid from one place to another and let it out in a certain spot. Flow rate is one of the most important things to think about when designing something, because it tells you how much fluid needs to be moved per unit of time. Overall, to design a system for delivering fluids, you need to know a lot about the different part of the process. By considering the flow rate, head loss, and physical properties of the fluid, and choosing the right materials and motor pump, it is possible to make a system that is both effective and safe. But it's important to remember the rules and check with the people to make sure the system is in line with them. That's all from me. Thank you very much.